Okay, in this video, we're going to be looking at one of the more challenging examples of a problem you might see in gases. So this is when you actually can take the ideal gas law and apply it to stoichiometry, which is a skill that we've already had a lot of practice with through previous units. So the question here tells us that ammonium sulfate, which is a fertilizer, can be prepared by the reaction of ammonia with sulfuric acid, and here we'll assume they're gases. Calculate the volume of ammonia needed at 42 degrees Celsius and 15.6 atmospheres to react with 870 grams of sulfuric acid. So the first thing we should do is just make sure we go through and identify all the information that we have. So the temperature, we know that that's 42 degrees Celsius, and we're going to have to convert that into Kelvin. And we remember when we want to go from Celsius to Kelvin, we add 273.15. So our temperature is going to be 315.15 degrees Kelvin. And what else do we have? We know that we know the mass of the sulfuric acid, which is 870 grams, so quite a bit, quite a large process there. And because we have the mass, but you remember from the previous units on stoichiometry, we can't compare masses directly, we have to compare moles. So when we're performing stoichiometry, we'll need values of moles, which means that we're going to need to know the molar mass of that compound as well. So the molar mass of sulfuric acid, just for the sake of time in this example, we generally know and can quickly calculate molar masses. It's 98.0784 grams per mole. So that's some information that we have. We also know the pressure. We are given 15.6 atmospheres. That's the unit of pressure. So the fact that we're given pressure and that we're given temperature, even though this could seem like a normal stoichiometry problem, the fact that we're given those pieces of information, that pressure, that temperature, that's a really good clue to you that you should be looking at the ideal gas law. So our next step, before we start looking for more information, because we know that we're going to be looking for a volume, that's what's going to be unknown, and we also know that we're going to need the moles of sulfuric acid. So those are two unknowns. First, we're going to need to solve for the moles of sulfuric acid in this reaction. So we know that we're given 870 grams to use in this scenario. We know that the molar mass is 0.784 grams per mole. So then when we calculate the moles of that, just for the sake of quick numbers here, you'll get something around 8.87 moles. So that's actually quite a lot of moles of sulfuric acid. Now here is where we're going to need to perform stoichiometry, because we are asked for the volume of ammonia that's needed, which is that. But we are given an amount of sulfuric acid. So this is kind of like a mass to mole stoichiometry problem in that sense. So what we can do once again, like we've done before, we can set up our equivalent multiplier to figure out how many moles of ammonia are going to be needed. So if we have 8.87 moles of H2SO4 to use in the reaction, and we want to know how much ammonia is going to be needed, then we'll set up our multiplier. So we know the balanced equation, what that tells us, once again, is that for every 1 molecule of sulfuric acid, you'll need 2 of the ammonia to react completely. So that just means there's 2 moles of ammonia in the reaction per every 1 mole of sulfuric acid. And then we know we've set up that multiplier correctly because those units are going to cancel out. All right, so that's a skill that we've practiced quite a bit before. So then the 8.87 times that multiplier, we know that we're going to need approximately 17.74 moles of ammonia. So that's how much ammonia is going to be needed for this reaction to be complete. And you'll see here, we did solve for the moles of ammonia, or the moles of sulfuric acid rather, but then with that we were able to also determine the moles of ammonia. So I'm just adding that to the data list now just so that it's more clear that there was another step involved. So now we have moles, we have pressure, we have temperature, and we know that R is the constant. So we now simply need to apply the ideal gas law, PV equals nRT. And then we want to isolate volume on its own. That can be accomplished by dividing both sides by the pressure. So then volume equals moles times gas constant times temperature divided by pressure. And then we'll just sub in our information. Keep in mind here that we have to use a version of the gas constant that is consistent with the units that we're already given. And now since we were given pressure in units of atmosphere, that means we must use a gas constant with units including atmospheres. So R in this example is not 8.3145, it's 0.08206 liter atmospheres per Kelvin moles. So we just needed to recognize there were units of atmospheres for the pressure, and that's going to affect what goes into our equation. So now we'll just sub in all of our information. So 17.74 moles of ammonia multiplied by that gas constant 0.08206 liter atmosphere per Kelvin mole times what was our temperature, 315.15 Kelvin, and then divided by the pressure, which was 15.6 atmospheres. And then we type that into our calculator to get a final answer, just for the sake of speed. Rather than typing it in, I know that the answer is 29.41 liters. And that's our volume of ammonia that's going to react. So therefore, 29.41 liters of ammonia are needed. So just to recap what we were doing here, now in this example we started with a balanced equation. It's very possible that you like for a gas law problem you'd likely be given the equation, or at the very least you'd be told the reactants and products. But it's possible that you might need to predict the products of reactions, which you all can do at this point in the course. So we identified the equation, reactants and products. We looked to the information in our question. We created a data list, making sure temperature was in units of Kelvin. We knew that we were given a mass of sulfuric acid, and we know that we have to compare moles in stoichiometry. So we determined the moles of sulfuric acid, and then we set up our equivalent proportion multiplier as we did in previous units in the course to figure out how many moles of ammonia would be needed, because we were asked for a volume of ammonia, right? Then that became N in the PV equals nRT equation. We identified the correct value of R to use based on the units because we were given units of atmospheres. We subbed in all of our information down here, returned a final answer, and that's how we determined the volume of ammonia that would be needed to react with the sulfuric acid.